Today we're working on lesson 33 from equations to inequalities. So remember those inequality signs, greater than, less than, greater than or equal to, less than or equal to, the ones we already have in our notes from earlier this module. So we're going to be looking at these equations and finding out when it's a true number sentence and when it's false. For directions say, what value or values does the variable have to represent for the equation or inequality to result in a true number sentence? And then what value or values does the variable have to represent for the equation or inequality to result in a false number sentence? So A says y plus 6 equals 16. So that means we're thinking, what would y have to be for this to be a true number sentence? Well, we know that one way to find that is to take 16 minus 6, and 16 minus 6 is 10. So 10 plus 6 equals 16. So that would mean that y equals 10. So the number sentence is true when y is 10. So we say true when y is 10. False is any other number. There is not another number that is going to make that number sentence true. It would only be true when y is 10. B says y plus 6 is greater than 16. So we have the same expression on this side and the same value on this side, but a different sign, which is going to change our answer. So y plus 6 is greater than 16. So we have to think, well, we know this side of the equation is going to have to be greater than 16. So what could y be to make that true? Well, if we know 10 plus 6 is 16, then any number greater than 10 is going to make this true. So we would say true when y is greater than 10. So true when y is greater than 10. False is when y is any number (10) or less. So 10 would not make the sentence true, or any number less than 10. Letter C, y plus 6, again, we see that same expression, but this time it says y plus 6 is greater than or equal to 16. So that means that this side of the equation, the y plus 6, can be greater than 16, or it can be equal to 16. So this is kind of like taking these two number sentences and putting them together. So for this one, we know that it would be true when y is 10 or any number. I'll move this over a little bit. Greater than 10. So true when y is 10 or any number greater than 10. False when y is less than 10. Letter D. So again, for D, E, and F, they're going to give us an equal sign so we can find the equation. Then we're going to have a less than and then a less than or equal to. So 3G equals 15. I'm going to make this a little larger. Well, what I know is that a number and a letter together are multiplication. So 3 times what would give me 15? How many groups of 3 are in 15? And the answer to that is 5, because 3 times 5 equals 15. So this sentence is true when G is 5, and it is false when it's any other number. So when we have the equal sign, it's one definite answer. For letter E, 3G is less than 15. So that means that whatever I'm multiplying 3 by, the answer has to be less than 15. So I know that I couldn't actually use 5, because 3 times 5 is 15. It's going to have to be a number less than 15. So this number sentence is true when G is less than 15, less than 5. Now remember, we don't want to say 4 or less because it could even be a decimal. So we just want to say true when G is less than 5, any number less than 5. False would be when G is any number 5 or greater. Because 5 would give us that answer of 15. And any number greater than that is going to be greater than 15, and we want it to be less than. So false when G is any number 5 or greater. And then last on this page, F says 3G is less than or equal to 15. And remember, if you're confused about the signs, go back to that chart that we have in our notes and make sure you're using that. So 3G is less than or equal to 15. So we know that whatever's here is less than, which is what it told us here, or also equal to. So again, we're kind of combining these. So that means this number sentence will be true when G is 5 or less. So any number 5 or less than 5 would make it true. It's going to be false when it's going to be any number greater than 5. False when G is any number greater than 5. Because a number greater than 5 is going to give a number, is going to give an answer or a product greater than 15. And we want a product that is less than or equal to 15. So example 2 is the same idea, gives us some equations, 2 different ways, the same expression on one side, answer on the other side, and then a different symbol in the middle, but it also gives us kind of like an answer bank. So it says, which of the following numbers, if any, make the equation or inequality true? So remember, it's an equation when it has the equal sign. It's an inequality when it has any of these other signs, less than, greater than, less than or equal to, greater than or equal to. So our answer bank is 0, 3, 5, 8, 10, and 14. So we're looking here and saying, what could M be? So M is our variable. M plus 4 equals 12. Well, I know that one way I can figure that out, if this is an addition, then I'm doing the inverse operation, which is subtraction, 12 minus 4. And I know 12 minus 4 is 8. So I'm going to plug that in and see if that's true. 8 plus 4 equals 12, and it is. So I know that M is going to equal 8 for that equation. So again, if it's an equation, I'm finding one definite answer. Letter B says M plus 4 is less than 12. So I want to see which of these could apply if M plus 4 is less than 12. Well, I know 8's not going to work because 8 plus 4 is 12. But I could try 5. 5 plus 4 is 9. So I know that's going to be less than 12. 3 plus 4 is 7, so that would work because that's less than 12. And 0 plus 4 is 4, so that's less than 12. So my possible answers there are 0, 3, and 5 would all make the number sentence true.